Welcome to this presentation on Linux swap management. Here, we will understand the importance of creating and managing swap space in Linux systems. Swap space is a designated area on a disk that acts as an extension of your system's physical memory, also known as random access memory, or RAM. It provides virtual memory when your RAM is full. Swap space can be either a dedicated partition on your hard drive or a file. Although it is slower than RAM, swap space prevents system crashes by providing extra memory when your RAM is completely utilized. There are several key reasons to use swap space. First, it prevents out-of-memory errors. When your physical RAM is exhausted, the system can move inactive pages to swap space. This action prevents application crashes and maintains system stability. Second, swap space supports hibernation. It is required for system hibernation, as the contents of RAM need to be saved to the disk before powering off the system. Third, it improves memory utilization. The kernel can move rarely used memory pages to swap, which frees up RAM for more active processes and file system cache. Finally, it enables memory over commitment. Linux can allocate more virtual memory than physical RAM available. This allows more applications to run simultaneously, even when not all applications need their full allocation at the same time. There are two primary types of swap space: swap partitions and swap files. A swap partition is a dedicated disk partition specifically allocated for swap usage. It is created during system installation or by repartitioning the disk. Swap partitions offer better performance, have a fixed size, and experience less fragmentation. However, they require repartitioning. Their size is not easily changed, and they use dedicated disk space. A swap file, on the other hand, is a regular file created on an existing file system that is designated for swap usage. It can be created, resized, or removed without repartitioning. Swap files are easy to create and remove, offer flexible sizing, and do not require repartitioning. However, they may have slightly lower performance, potential fragmentation, and introduce file system overhead. Here are the steps to create a swap partition. First, identify available disk space using the fdisk or partit command to find space for your new partition. Second, create a new partition with the Linux swap system identification, which is 82. Third, format the new partition as swap space using the command mswap. Fourth, enable the swap space using the swapon command. Finally, make the change persistent by adding an entry to the file /etc/stab to enable the swap at boot time. Here are the sample commands. First, list disk partitions using the command sudo fdisk -l. Next, create a new swap partition using the command sudo fdisk /dev/sdb. In the fdisk utility, you can use the following commands. Type in for new partition, P for primary partition, enter the partition number, accept the default first sector, specify the size such as +2 GB, type T to change the partition type, enter the partition number again, enter 82 for Linux swap, and finally type W to write the changes. Then, format the partition as swap using the command sudo mswap /dev/sdb3. Now enable the swap partition by typing sudo swapon /dev/sdb3. Finally, add the following line to /etc/stab to make the change permanent: echo single quote /dev/sdb3 none swap sw 0 single quote, pipe sudo t -a /etc/stab. Here's how to create a swap file. First, create an empty file of the desired size using dd or fallocate. Second, set secure permissions of 600 to prevent unauthorized access. Third, format the file as swap space using mswap. Fourth, enable the swap file with the swapon command. Finally, make the configuration persistent by adding an entry to /etc/stab to enable the swap file at boot time. Please note that fallocate is faster than dd, but may not work on all file systems. Use dd if fallocate fails. Here are the sample commands. First, create a 2 GB swap file using dd with the command sudo dd space if equals /dev/0 space of equals /swap file space bs equals 1 MB space count equals 2048. Alternatively, you can use fallocate with the command sudo fallocate space -l space 2 GB space /swap file. Next, set secure permissions using the command sudo chmod space 600 space /swap file. Then, format the swap file with the command sudo mswap space /swap file. Now, enable the swap file using the command sudo swapon space /swap file. Finally, add the following line to /etc/stab to make the change permanent. Echo space single quote /swap file space none space swap space sw space 0 single quote pipe sudo t space -a space /etc/stab. Here are some useful commands for managing swap space. For monitoring, you can use the free command to display the total amount of free and used physical and swap memory in the system. For example, type free space -h. You can also use the command swapon space --show to show summary information about swap devices and files currently in use. Another command, cat space /proc/swaps, displays detailed information about all swap devices currently in use. Finally, vmstat reports information about processes, memory, paging, block input-output, traps, and central processing unit activity. For example, vmstat space 1 space 5. For management, the swapon command enables a swap device or file for use by the system. For example, sudo swapon space /dev/sdb2. The swapoff command disables a swap device or file, removing it from the system's swap space. For example, sudo swapoff space /swap file. The mswap command sets up a Linux swap area on a device or in a file. For example, sudo mswap space /dev/sdb2. Lastly, the swapiness setting controls how aggressively the kernel swaps memory pages to the disk. For example, echo space 60 space pipe sudo t space /proc /sys /vm /swapiness. Here are some best practices for swap management. First, ensure appropriate sizing. For modern systems with ample RAM, use 1 to 2 times RAM for hibernation support. For systems with less than 2 GB of RAM, use 2 times RAM. For systems with more RAM, a smaller swap such as 0.5 times RAM may be sufficient. Second, adjust swapiness. Tune the virtual memory.swapiness parameter, ranging from 0 to 100, to control how aggressively the kernel swaps memory to the disk. Lower values reduce swap usage and higher values increase it. The default value is 60. Third, use fast storage. Place swap on fast storage devices like solid-state drives for better performance. Avoid using network storage or slow mechanical drives for swap, when possible. Fourth, secure swap files. Set proper permissions with the command chmod 600 on swap files to prevent unauthorized access. Consider using encrypted swap for systems with sensitive data. Fifth, perform regular monitoring. Monitor swap usage with tools like free, vmstat, and swapon. High swap usage with available RAM may indicate memory leaks or a need for swapiness adjustment. Sixth, consider using multiple swap areas on different physical devices to improve performance through parallel input-output operations. Set priorities with the priority equals option in /etc/stab. Key takeaway. Swap space is an essential component of Linux memory management that provides overflow capacity when RAM is full. While modern systems with ample RAM may use swap less frequently, it remains important for system stability, hibernation support, and efficient memory utilization. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.